Would I be able to hear a football crowd cheering from a stadium miles away? Sound travels at approximately 343 meters per second at 68 degrees Fahrenheit and 20 degrees Celsius. What does that mean? The speed of sound increases or decreases depending on the surrounding environment. For example, when I shout in warmer air, the sound waves travel faster. However, there's a catch. The sound waves in a warm environment would not travel as far as sound in a cooler environment. Imagine two runners. One is a sprint runner while the other is a marathon runner. The sprint runner runs faster but covers less track, while the marathon runner runs slower but eventually covers more track. In this case, the sprint runner would be a sound wave in a warm environment, and the marathon runner would be a sound wave in a cool environment. So, the chance or probability of hearing the football crowd cheer, if it's in a cooler environment, is higher. Unlike light, sound needs a medium, or something with mass, to travel. When the air is hot, the molecules in the air are moving faster, which means there's more kinetic energy. And the more kinetic energy, the more thermal energy. Bringing it back to sound waves, the more faster the molecules in the air move, the more easily the wave can get through. So sound travels faster and hotter. But that means the wave would be traveling in all directions. But what about cooled? In cooler, there are actually small warm air pockets above the cooler. So the sound bounces against the hot air pockets without reducing its frequency, allowing the wave to travel faster. Just like a ball bounces against this glass without losing its speed in a perfect world. But don't get too excited. This doesn't work in snowy places because snow absorbs sound. That's very interesting, but why does this matter? Sound waves are how we communicate, and this can possibly help us further improve hearing technology. It can change how people experience the world around them. After all, that's what science is.